So in this section, we're going to go over arithmetic sequences and series. We're going to talk about what an arithmetic sequence is, and we're going to look at the formula for finding the different terms in an arithmetic sequence, and we're going to look at a formula for finding arithmetic series, or the sum of those terms in an arithmetic sequence. So first, what is an arithmetic sequence? An arithmetic sequence is a sequence of terms that differ by the same number. So you get each term by adding the same number to the term before it. So for example, here we have 6, 13, 20, 27. So to get each term, we take the term before it and add 7. That is our common difference. The number that you add each time is D. And in fact, to find D, you can take a term and subtract the one before it. So if I take 20 minus 27, I get 7 for my common difference. That works if I subtract any of these, 20 minus 13, 13 minus 6. And to get the next term, I would add the common difference. So if I add 7 to 27, I know that the next term will be 34. So in this example, I'm trying to find first a sub 1. A sub 1 means the first term in the sequence. So here, this is the first term of that sequence. So a sub 1 is 4. And then if I subtract any of these terms, 24 minus 19, 19 minus 14, 14 minus 9, or 9 minus 4, I get 5 for the common difference. B, our first term, is 34. And if I subtract any of these, so 27 minus 34, notice we're going down each time. So our difference is going to be negative because I'm adding a negative 7 to get to the next term. In the last sequence here, we have our first term is 2, and then to get to the next term every time, we are adding 1/2. So the formula for finding any term of an arithmetic sequence is this a sub n, which stands for the term that you want to find, equals a sub 1, the first term, plus how many terms you have in that sequence between a sub 1 and a sub n, that's what n is, minus 1 times the common difference. This makes sense because we take that first term and we're adding, if n is the next one, so the second term, 2 minus 1 is 1, times the common difference. We're just adding the common difference. If we want the third term, we should be multiplying 2 times the common difference, and so on. So that's why this formula makes sense. So we're trying to find a sub 14. We know that the first term is 4. We know that the common difference between each of those terms in this series is 3. And we're trying to find the 14th term. That's n. So our formula is a sub n, so the 14th term is a sub 1 plus n minus 1 times d. So that's 4 plus 3 times 13. That's 39 plus 4 is 43. Now in this example, we're using the same formula, but this time we want to know which term is 301. So we're trying to find n in this particular question. So again, we have all this information where a sub 1 is 4, d is 3. This time we don't know n, but we do know a sub n is 301. So a sub n equals 4 plus n minus 1 times 3. So if I subtract 4, I get 297 equals n minus 1 times 3. If I divide 297 by 3, I get 99. And then add 1 to both sides to get n equals 100. So it's the 100th term that is 301 in this particular sequence. Now in this problem, we're given two pieces of information. We know that the third term is 8, and we know that the 16th term is 47. But for the formula, we need to know a sub n, which in this case would be 16, but we also need to know a sub 1 and d, and we don't know either of those. So what we can do is we can use the formula with both of those as being variables. So in this case, our a sub n is a sub 3, and that's 8. So 8 equals, we don't know what a sub 1 is. We know that n is 3 because that's the third term. And we don't know what d is. Solving this, get that. Over here we're going to do the same thing. This time 47 is our a sub n, and n is going to be 16. So that gives us this equation. So now these are two linear equations. We can use substitution to solve for one of those variables. So if I solve this for a sub 1, I get 8 minus 2d. If I plug that in for a sub 1 over here, and then I combine my terms. So if I subtract 8, I get 39. Negative 2d and 15d gives me 13d. So my common difference is 3. Plug that back into either of these equations. So I'm going to go ahead and plug that back into this equation right here to get that a sub 1 is 8 minus 2 times 3. So a sub 1 is 8 minus 6, or 2. So that means my sequence starts with 2, that's a sub 1, and then I add 3 every time, so the next term is 5, 8, and so on. So a series means that you add n number of terms in the arithmetic sequence. So the formula, if you have an arithmetic sequence for the sum of n terms, is to take the number of terms and divide it by 2 and multiply that by the sum of the first term and the last term in that sequence that you're adding. So if I'm trying to find the sum of the first 100 natural numbers, first, what does that mean? Natural numbers are just your counting numbers. So your sequence is going to be 1, 2, 3, and we want to to go all the way to 100. So that tells us that our first term is 1. Our last term is 100. And there are 100 terms in this sequence. So S sub 100 is equal to n divided by 2 times the first term plus the last term, and that gives us 50 times 101, which is 5,050. In this sequence here, we're trying to find the sum of the first 15 terms of the arithmetic sequence. So again, a sub 1 is 4. Then we know that n is 15. The problem is we don't know what a sub 15 is. So we have a couple of choices. We could keep adding d, which we can see is 3, until we get to the 15th term. That's going to take a while though, and say we had to find the 100th term, that's not going to be the best way to do that. So if we want to find the 15th term, we're going to use the a sub n formula. So a sub 15 is the first term plus n minus 1 times the common difference, which we said was 3. So that's 4 plus 14 times 3, so that's 46. Now that we know a sub 15, we can find s sub 15 by using that formula. So that would be n, which we said is 15, divided by 2 times the first term plus the last term, and that gives us 375. Remember that this is another notation for using sums, and the way that we know that this is an arithmetic sequence is because this is a linear equation. So anytime inside the summation your equation is a linear equation, that tells you that it's an arithmetic sequence, and you can use the sum formula. So to use the sum formula, we need to know how many terms there are. This right here, since it's 1 to 130, will help us to figure out how many terms there are. So n is 130, because that's how many terms there are from 1 to 130. Then our first term we have to figure out by plugging 1 into this equation here. Our 130th term, we'll plug 130 into that equation. And that gives us 525. And now we can find S of 130 by doing n divided by 2 times the first term plus the last term, and that gives us 34,710. All right, now we're going to look at a couple of word problems and how to figure out what they're asking us to do here. So in this word problem here, we can see that we have a starting number here. This 1425 is our a sub 1. We know that this is an arithmetic sequence because it's going up 15 cents every hour. So if we talk about Kendall's wages go up 15 cents every hour. So each term represents Kendall's wages, not every hour, every 2 months. Every 2 months. So our common difference is 0.15. So Kendall starts off at $14.25, and in 2 months we'll add 15 cents to that to get her next hourly wage. So the question is asking, after 5 years, what will her hourly wage be? So we're looking for a sub n, but we have to figure out what n is. So we don't want years. N's not 5 because it goes up every 2 months. So we need to know how many 2-month periods there are in that 5 years. Well, 5 years is 60 months. So we take 5 years times 12. Well, 60 months is actually 30 2-month periods. And so n is going to be 30. And so we're looking for a sub 30. So we take the first term plus n minus 1 times the common difference of 15 cents, and that gives us $18.60. So after 5 years, her hourly wage will be $18.60 an hour. Now this one is asking for the sum and not a certain term, because it asks how many poles are in the stack total. So it tells us in the very top, or in the very bottom row, there are 30 poles, and then as it goes up, it loses a pole each time. So my sequence goes 30, then 29, then 28, and so on. So that tells me my first term is 29. It also tells me that in the top row there are 5 poles, so that's my last term. And we know that the common difference between each row, the number of poles in each row, is -1. It's going down by 1 each time. What we don't know is what is n. So that's what we need to figure out. So we're going to use our arithmetic sequence equation first. That says a sub n, which is 5, equals a sub 1, 29, plus n minus 1 times the common difference. So if I subtract 29, I get negative, a sub 1 is 30, not 29. So if I subtract 5 minus 30, I get negative 25. If I multiply both sides by -1, I get 25. So that tells me n is 26. So now I need to find the sum of all those rows to know how many poles there are total. So S sub 26 is 26 divided by 2. The first term is 30 plus the last term is 5, and that gives us that the whole stack has 455 poles.